Hey everybody, welcome back to the channel. Today we're going to do part 2 of Windows networking in C++. So the first thing, I linked code down in the comment section below, but I decided I was going to go ahead and put this in a header and a CPP file. So I'm just going to package the entire Visual Studio project and I'm going to put it in the Dropbox and send that link and put that link in the video description. So I just made a couple of small adjustments. I do not allow copies and I do not allow moves on this WinSock library object. So it just makes things a little simpler. Since startup and cleanup works for all threads created, there's only need to call it one time. So it's the first thing that's being called in main. In today's video, we're going to go over the socket function. And so here in WinSock library.hpp, I already have WinSock 2, the header being included, so we don't have to include it here in main. It just keeps the code a little cleaner so you can more easily understand what's going on. Okay, so the socket function, if you look on MSDN, this function creates a socket that is bound to a specific transport service provider. Okay, the first parameter is the address family. We're only going to be going over AFINet and AFINet 6. Now, there is also Bluetooth and there is IPv6 mapped v4 addresses. Those are more complicated topics, and eventually we'll get to those. But in this video and in the future few videos, we're only going to be using IPv4 and IPv6. So the first thing is the first parameter is the address family, so AFINet or AFINet 6. The second parameter is the type. We can create a stream-oriented socket, which is useful for TCP, or datagram, which is useful for UDP. If the value of the third parameter is 0, the caller does not wish to specify a protocol, and the service provider will choose the protocol to use. So we don't have to specify it here, but we could, in theory, just put 0. I'm going to make it explicit, and we're going to call IP proto TCP or IP proto UDP. This way, it's clear what's going on in the code, because sock stream isn't very clear. Like if you do a lot of network programming, you understand what's going on, but if you're new and you see this, you're like, well, what's being created here? Why is the third parameter 0? And then if you see 0, you're like, what is this? But if you see IP proto TCP, you know you're creating a TCP socket. There is another one here. That's the Bluetooth protocol. Again, we're not going to be going over Bluetooth, but this will be used in a later video. So just for now, we're going to ignore all Bluetooth communication stuff. It's just UDP, TCP, IPv4, and IPv6. So with those three parameters in mind, let's get started. So the first thing is, type in Windows for a socket is called socket. If you're on Linux or if you're using any Berkeley sockets framework, I think older versions of Mac use this, the return type is simply going to be an int. But in our case, we're just going to do socket. And I'm going to call this TCP socket v4. So this is going to be a version 4 TCP socket or an IPv4 TCP socket. So to do this, you call the socket function. AFINet is IPv4. Sock stream, which says that we want handshakes and stuff involved. And IP proto TCP, which again is not needed if you classify sock streaming. You pass 0. Every single thing Windows XP and up will create a TCP socket. But we're just going to specify it here. The second type of TCP socket we're going to be going over today is a V6 socket. This is a IPv6 socket, and that's AFINet 6. That's the first parameter, and the last two parameters are exactly the same. So this is how you will create an IPv4 and an IPv6 TCP socket. So now, what about UDP? Well, those are just as easy to create. We'll first create a v4 version of a UDP socket. So AFINet for IPv4, sock dgram, which is datagram, which is UDP. So the D in UDP is datagram, and IP protocol UDP. And now we're going to do the same thing to create a V6 socket, except this time we're going to do AFINet 6, sock dgram, and IP proto UDP. So these are the 4 type of sockets that we are going to be creating at least in the next few videos. Now, I don't know why, if you're in Visual Studio, you'll see this weird thing. It says UDP socket v4 holds a value that must be examined. This is because this is something new. When you call, it's something new in Visual Studio. When you call socket, there is a chance that the socket can be invalid, that it can be in an invalid state. So the easiest way to go about doing this is to simply do a check. And the way we check if the socket function created a socket successfully or not is to simply compare, we'll say invalid socket. We'll simply compare it to invalid socket. If it is, we'll return 1. Okay? So we can do this by passing in Bluetooth like this. I actually don't know if this will fail because I'm specifying TCP. Okay, it did. So it exited with code 1. That's because you can't have a Bluetooth socket with an IP protocol TCP. Okay, sock stream is the right type of socket for Bluetooth, but that's not going to work in our case. So we now have created a socket and we know how to check if the socket is invalid or not. But when you're done using a socket, you also have to call another function called close socket. Now that we've gone over how to create the different types of sockets, I'm going to erase this for now and just stick with TCP v4. So we have this socket. If it's invalid, we return 1. Okay? And then down here, we're going to call close socket. But what if I were to return here or throw an exception? What happens? Close socket never gets called, and the socket never gets closed, therefore leaking a system resource. Now, again, I don't think this is a big problem on Windows, but you still should not leave the responsibility up to the operating system to clean up. You should still call close socket, even if you are on a good system, because another system may use a similar function, and it may not automatically detect or clean up or just whatever. So whatever your system that you're on, if it has some sort of garbage collection once the process closes, don't rely on that. Close your resources. And there's really one good way in C++ to do this, and that's using an RAII type. And so basically on construction, the socket will get set, and on destruction, close socket will be called. So we're just going to create a class, and we're just going to call this like safe socket. It's going to have 1 member, and it's going to be defaulted to invalid socket, right? So its default state is invalid. Now we could also just make this a socket, and we could provide the functionality to create a socket like this. Int type, int proto. So this is one way to do this, but there's also an even easier way. Since in our case, we're only going to be using IPv4 in UDP and TCP sockets, we could either create multiple classes, one for UDP and one for TCP, or we could specify a socket type enum. So we could just create an enum class here called type UDP and TCP. Okay, the order does not matter because we're going to use a switch statement. And then we can take in a type and a constant. I'm just going to call it address family. And we'll default it to AFINet for IPv4. And now that we have this constructor, we can simply call and socket we can pass in the address family. Default throw, logic error, invalid type, something like that. To just create the cases. And here we'll just create the socket. We'll pass in the address family. Now the type, we know what the type is. It's sock stream, again, IP proto TCP. And so now it's clear as day what we are creating. And remember, UDP gets dgram and IP proto UDP. And then if msocket equals invalid socket, throw we can just get the last error from the WSA framework and we can call system category. Okay, and this is our constructor. Although it looks nasty and ugly, there's a couple things that we could do. We could break up this switch statement and put it into a private function called create socket. So let's do that now. I'm going to create a separate private section. I'm going to make it static because it doesn't need to belong to a single object. We can do const type and then we can do const int AF just to make it shorter for us. We can guarantee this does not throw exceptions, and we can inline the function. So now we can move this down here. Oh, you know what? This can't be static because I need access to the data member. Okay, so create socket. That's done. And now we need to pass in our arguments. So we can do msocket msocket. We can pass in our arguments here for type and address family. And this right here should create the socket. If it throws an exception, oh well, because you're doing weird stuff anyway. And if it's invalid, we throw a system error. We need a get function, which will be const and not throw an exception. This one here will also not throw an exception. If msocket does not equal invalid socket, we can just ignore the return value of closed socket and pass in our actual socket. And that's it, the shortest code possible. Okay, so what else is there for us to do? So far, I'm going to leave it just like this, and we're going to go over how we can use this framework to actually create a socket. First thing, notice we get rid of the if statement. And now we can have a socket type, TCP, and address family of AFINet. Okay, and this makes it so much easier because now you can see clear as day what kind of socket's being created. And then, of course, we can add extra functionality here, and this protects it. But what if you, first off, you shouldn't copy a socket like this. A socket is like a unique resource. So we're not going to allow copies. but we will allow moves. So the way to do this is we need to disable copies. So that's the copy constructor. We need to copy assignment operator. And now we can set up our other socket and get it to come in. And we went over STD Exchange in the last video. Again, it's no longer being used in the WinSock library class, but it will be used in this class. And then the move assignment operator, msocket, if msocket does not equal invalid socket, what we need to do is we need to call close socket, because when you're in move assignment operator, your object can actually be in a valid state, and it's important for us to get rid of that. So we can just close the socket, and then msocket is going to equal std exchange msocket dot right hand side dot msocket and invalid socket. Okay, so return pointer this. I always forget that. All right, so now we can safely use this object without risking a leak. There is one more thing I want to do. I'm going to create an enum class, call it address family. And I'm just going to call this IPv4, IPv6. We can make this equal those here, the proper ones. Or you can research them however you want to do it if you want to hide the header. Okay, and of course it's not right. It's technically inet, but I'm cool with this. And then here we're going to pass in the address family. And we need to make one more change here. Oh, actually, you know what we can do? Static cast input. Boom. It's a private. We know that these are valid types. So now if I wanted to create an IPv6, I could do socket address family IPv4 or IPv4 or IPv6. Okay, so we're creating a TCP socket, well, version 4. Close socket goes away, and because of those exceptions, there's no need to check it. Now we have a good way to create the two types of sockets that we're going to be using in the future. And so now what I'm going to do is I'm going to connect to Google. So I need to include a header. Again, we'll go over these functions later. Right now, we're just testing, so I can show you that everything works. But we're just going to include WS2 TCP IP, and that's going to allow us to call the get address info. I'm going to call this hints. I'm going to pointer p results. And then I'm going to do socket address in for address. And now we're just going to do if get ADDR info. The first thing we need is we need a node name, google.com on port 80. The hints, we'll pass that in, and the results. If it does not equal 0, we can simply return 1. Now hints needs to be filled out. The first thing we'll do is we'll do the address family. The socket type, I want sock stream. There's another one, yeah. Protocol, IP, proto, TCP. And I think that is all we need. And then we have results. We know if we get down here, we need to call free address info. Because again, this right here is all based off C. So what we're going to do is in between getting it and freeing it, okay, we are going to assign this address. So the way that we're going to do this is we're going to call mem copy _s. And the first thing is we're going to pass in the address, size of address. And then we're going to get p results, addr, p results, address length. Okay? And this will allow us to copy the memory safely. Once the memory is copied, we can free, and then we can call connect. And on the socket, we're going to do TCP socket v4.get. The name, we have to reinterpret cast to a const socket address pointer. Pass an address and then size of address. So now we can create a string for a request. Pass in the host. And we're going to pass in a user agent. We're just going to call this test agent. Carriage return line feed, carriage return line feed. And then simply call send. We get that. We pass in the request string length of request. Flag to 0. And now I can get a char buffer 1024 times 4. We'll just do a 4 kilobyte buffer. We will receive I'm just going to get the size so I can write it out, the standard out. And we're going to pass in our buffer. And the length is going to be 10. Well, we can just use size of buffer. And now we need to include IOString. So we can see what the output is. See out that right. Here we'll write the buffer with the size. All right, and let's see what we get. Oh, look at that. Of course, it says move permanently, blah, 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 but we are getting actual data from the web server, which is really cool. So, the other thing we need to make sure of is that this right here is being called on that socket. And look at that. It is being called. It's closing the socket. Perfect. So, as you can see here, we have an easy abstraction to create sockets that take almost no time at all. Now, there is another type of socket that you guys need to be familiar with at least, and that's an IPv6 mapped v4 socket, which is an AFINet 6 socket, but can map to IPv4 addresses. And we'll go over this in a later video, but for now we're going to leave our code exactly like this because that's a more complicated and nuanced subject, right? Like, how many times do you actually need mapped v4 addresses? It's if you're using IPv6, you're probably definitely going to need them, but for most applications, IPv4 is sufficient enough. There's almost no extra. I hear this all the time. IPv6, it has extra security built in. there's no truth to that, okay? If a hacker wants to get into your system, if you're using IPv4 or IPv6, it's just a little harder for them to guess. But if they wanted to DOS your system, your public IP address is an IPv4 address anyway. Like by your internet service provider, you're not getting around hackers by using IPv6 addresses. The main reason people use IPv6 addresses is because we're running out of the possible numbers for IPv4. So IPv6 addresses greatly and dramatically increases the number of IP addresses available to the general public. That was the main reason for its creation. Don't let anyone tell you it has extra security protocols or anything like that. I mean, it has a couple things, but it doesn't do much. If someone wants to get into your system, they can just as easily do it with IPv6 as they do with IPv4. So don't do it for security reasons. Do it for compatibility. Okay. So if like you specifically have like an API somewhere that you need access to and it only uses IPv6, that would be a good reason to use IPv6. If you have a small server and a client application, like one I'm making now called Remote Desk, I have no need for IPv6 addresses. I'm just using IPv4. So, it's going to be it's going to determine how your application needs to be structured, what kind of calls you have to make, what kind of networking you need if you're calling APIs that only use IPv6. And if you are writing an IPv6 server, most definitely you would probably want to integrate IPv6 mapped v4 addresses so that someone with an IPv4 address can actually connect to your IPv6 server. So it's all up to you how you want to write the code. But in all the demonstrations that we're going to be doing in the future, except for maybe a video specifically designed for IPv6, we're going to be using IPv4. So we'll go over more of this functionality in the next video. But for now, this is it. I'll provide this code for this socket class, and it will allow you to easily create sockets. Safely create sockets too. The only thing that's necessary if you're on Windows is this WinSock library object that's right here. You kind of need that, and I just wrapped it in a cute little namespace called JP3. So I'm going to format this socket out. I'm going to put it in a header in a CPP file, and I'm not going to add any functionality other than what's already here. And I actually may strip the CPP files and just do header only because I think that's going to be fine for what we're trying to achieve. And I will see you guys in the next video. Have a good one.